to LearnCast. My name is Elsa, and today we will be learning about an intro to acids and bases. To start off, we will be talking about the properties of acids and bases. We use properties such as taste, feel, pH, and indicators to differentiate the two. Now, acids have a sour taste, rough feel, pH is over 7, and the litmus indicator would turn red, while the phenolphthalein indicator remains colorless. Bases, on the other hand, taste bitter, have a slippery feel, have pHs lower than 7, and the litmus indicator would turn blue, while the phenolphthalein would turn pink. It's important to note that there are also neutral substances, such as pure water, that have pHs of 7, that are neither acidic nor basic. Now that we've learned a little bit more about properties, let's talk about the definitions we use. There are 3 main definitions we go by to better understand the process by which acids and bases come to be. The first is Arrhenius. This states that in an acid, a positive hydrogen ion, H+, is donated. An example would be hydrochloric acid, which receives the H in HCl. Chlorine has a negative charge, so it receives the positive hydrogen ion. The Arrhenius definition also states that in a base, a hydroxide ion is donated. This example would be the OH in NaOH, or sodium hydroxide. The Bronsted-Lowry definition is the most common one that we use. It states that an acid donates a proton, which is the same as a hydrogen ion, because it has no electrons and 1 proton. It also states that a base accepts the proton, or positive hydrogen ion, like in nitric acid, or NH3. The last definition is the Lewis definition. This states that acids accept an electron pair, while bases donate an electron pair. Now, this definition is not as commonly used, but it is still important to know. Now let's move on to the reactions themselves. There are 3 main reactions we use to represent the production of acids and bases. The first is when a metallic oxide, such as lithium oxide, reacts with water, H2O, which are the 2 reactants, to produce a base resulting in lithium and hydroxide, which are the 2 products. The second is when a nonmetallic oxide, such as carbon dioxide, CO2, reacts with water to produce an acid. In this case, it would be carbonic acid. The third is when a metallic hydride, like sodium hydride, reacts with water to produce a metallic hydroxide and hydrogen gas. In this case, the products would be sodium, hydrogen gas, and hydroxide with their appropriate charges. Next, let's talk about conjugate acid and base pairs. So acids donate a positive hydrogen ion, or H+, to become a conjugate base. It would be beneficial for you to write down this next example so you can follow along. In the reaction of nitric acid and water, we have HNO3 plus H2O yields H3O plus NO3 minus. The HNO3 would be the acid, while the H2O acts as a base. On the product side, we see that H3O plus is the conjugate acid because it receives a proton. It changed from H2O to H3O plus, therefore it received a proton. And the NO3 minus is the conjugate base because it donated a proton. It changed from HNO3 to NO3 minus, therefore it's the conjugate base. Our next example shows how bases accept a hydrogen ion to become conjugate acids. Please write down this reaction so, again, you can follow along more easily. In the reaction of ammonia and water, we have NH3 plus H2O yields OH negative plus NH4 plus. In this case, the NH3, or the ammonia, is the base, while the H2O is the acid. On the product side, we see that OH negative is the conjugate base because it went from H2O to OH negative, and the NH4 plus is the conjugate acid because it went from NH3 negative to NH4 plus, which means it accepted a hydrogen ion, therefore being the conjugate acid. You may be confused as to how H2O of the two examples acted as an acid in one and a base in one. This is because H2O is amphoteric, which means it can act as both, because it has the capability of both receiving and donating a positive hydrogen ion. We follow a general rule, which is that acids only donate one hydrogen ion at a time, and bases can only accept one hydrogen ion at a time. However, there are certain acids and bases that have the ability to donate or receive more than one hydrogen ion. We categorize these acids and bases as monoprotic, diprotic, and polyprotic. So monoprotic acids can only donate one hydrogen ion. An example of this would be hydrochloric acid, which has only one hydrogen ion to donate, therefore it can only do one. An example of a diprotic acid would be H2SO4 or sulfuric acid, which has two hydrogen ions, so it can donate two, but they would be in two different steps, so it's still one at a time. And finally, we have polyprotic, which means that it can donate more than one. An example would be H3PO4, which is phosphoric acid. It has three hydrogen ions, so again, it can donate multiple, but they would all be in different steps, so it's still one at a time. Today we covered an intro to acids and bases, learning about their properties and distinguishing characteristics, the three reactions and definitions they can follow, and conjugate acid and base pairs. Thank you for joining me for our review. Be sure to follow us on Spotify, subscribe to our YouTube channel, and check our website to stay up to date with the latest releases. Until next time.